Today's lesson is on multivariable linear systems, and we're moving to three variables. So three variable equations and triples. Now we have this ax plus by plus cz equals z, and so on. Right? These would represent the three equations, and we're up to three equations because we also are up to three variables. Right? So your number of equations should match your number of variables, generally speaking, to find an answer. And again, our answer now, instead of being an xy point, is an xyz point. So it is a point in three dimensions. So it says use back substitution, also known as back sub, to solve the system of linear equations. So 2x minus y plus 5z is 24, y plus 2z is 4, and z is 6. And we kind of have this stair-step look to our equation here. Clearly, if we have z is 6, we just need to plug our number of z into equation 2. So y plus 2 times 6 is 4. This is 12, so subtract 12 from both sides, and get y is minus 8. So now we have a second variable, and now in the top equation, we're plugging in both. So 2x minus y is negative 8, plus 5 times z is 6 is 24. Cleaning this up, this is 8 plus 30, or 38. Subtract 38 from both sides and divide by 2. 2x equals negative 14, and I get x is minus 7. Now, again, with all these three circle pieces, we form our answer of negative 7, negative 8, positive 6 as our ordered triple. Now, row echelon form is what that stair-step pattern is called that we just found. Generally, your leading coefficients are 1, but that's not necessarily the rule. Right? So if you go back for a second and realize we had a 1y here and a 1z, but we had 2x. So it's not limited to being 1s in front. However, when you do the operation on your calculator, eventually, they will try to make sure it starts with 1. Gaussian elimination is how we would solve a system of equations into that row echelon form. So basically, we are going to do this process shortly here. So what are elementary row operations? Basically, what can we do to work on this eliminate? And it's just like with two variables, right? We can swap equation if that's going to help us. Most of the time, it's not necessary. We can multiply one equation by a number, right? So like 3 times equation 1, so we can add it to equation 2. And we can also do a combination of that, where I just said we're multiplying one equation, adding it to another equation to create a new one. Now, how elimination works is just like one variable. We generally try to use our multiplying LCM, etc., to eliminate. In this situation, right, we're using row 1 to eliminate the x's from the other two equations. Right, we say R2, R3 as in row 2, row 3, also known as equation 2, equation 3. Once we get rid of the x's, we will have a new row 2 and a new row 3, and we're then going to eliminate the y's in equation 3 using equation 2 and multiplication to get rid of them in 3. And again, by doing that, we started by getting rid of the x's, kind of making that first step. And then we get rid of the y's in the second equation, getting that second step. And then we hopefully will be left with some number of z equals a number, and we'll be able to solve. Once you're there, that's step 3. We're going to back substitute like we just did to solve the system. So here's how that looks in action. X plus y plus z is 6. 2x minus y plus z is minus 1. 3x minus z is minus 7. So again, I want to use this top equation to eliminate the 2x in the second equation and the 3x in the third equation. So one at a time, I need to multiply the top equation by a number that's going to be opposite, leave me with an opposite of 2x. So I'm going to do minus 2 times the first equation, or we'll just say row 1. So minus 2 times row 1, adding that to the current row 2, will get me my new row 2. So that's symbolically what I just said there. Negative 2 times row 1 plus what we have for row 2 will give us a new row 2. So I'm multiplying this top equation by 2 across the board. 2x plus 2y plus 2z is 12. And then I'm rewriting equation 2. 2x minus y plus z is negative 1. And we're just adding in our rows. 2x plus 2x, negative 2x. Gotta flip some signs here. They were negative, so this is going to be minus, minus, and a minus 12. There we go, fixed. And so now when we add, we should get 0x. This is why I caught my mistake. 2x plus 2x is 4x. The math wasn't wrong. I had made a mistake and forgot my negative sign. Now that we're set up, negative 2y minus another y is minus 3y. I owe 2z and have 1z, so I'm going to owe 1z. Negative 12 plus minus 1 is negative 13. So there's my new equation 2. Now clearly I don't need to write 0x, but that is how the elimination worked. We should end up with no more x. And next I need to do the same process, but to get rid of the x's in equation 3. So now I need to multiply by 3, and again negative 3 this time. Get it right, so this time I need to multiply row 1 by negative 3, add that to the third equation to get my new third equation. And so now, same idea as the last one, but this time I'll remember my negative. Negative 3 times x is minus 3x, minus 3y, minus 3 times z, and minus 18, and then rewriting this 3x, 0y, minus z equals minus 7, and again just adding. So we've got 0 here, minus 3y, minus 4z, minus 25. So now I have a new system, and it looks like x plus y plus z is 6. From down here, new row 2, negative 3y minus z is minus 13, and then my new R3 way down here, negative 3y minus 4z equals negative 25. And now I'm ready for the next step, right? We just created the first step. Now I need to get rid of these y's in the bottom. Well, negative 3y and negative 3y are opposites, so it's kind of up to you which way you want to do. Do you want to do row 2 minus row 3 or row 3 minus row 2? Either way works, I would say, because we have minus 4z. We might as well do R2 minus R3, giving us a new R3, and then we'll be ready to solve and back sub. So again, negative 3y minus z is minus 13. Second equation, third equation flipped to just positive. And now with quick adding, I get 3z is 12. And even better, now we can have an answer. Right? So now our final system looks like this, and then we're just going to back substitute and not rewrite the system again. And then lastly was 3z is 12. And now we're ready to solve. Right? So now to solve, using back substitution, 3z is 12, divided by 3, z is 4. Plug it into equation 2. Negative 3y minus 4 is negative 13, plus 4 to both sides, negative 3y, negative 9, divided by negative 3, y is 3. The last equation up top, x plus y plus z is 6. So x plus 3 plus 4 is 6. 3 plus 4 is 7. So subtracting 7, we get x is minus 1. For my final answer, minus 1, 3, 4 is my order triple. And that completes that problem. You can always plug it back into the original to double check that it worked. And it doesn't hurt to check your answer when it takes that long to get there. Next up, same idea. So we're trying it again. Number 2. These are opposites for my first step, right? Using x's to get rid of x's in the second and third equation. So we can just add row 1 plus row 2, or new row 2. And when they're right above each other, it might be a little bit easier. X minus x, 0, y plus 3y, 4y, z plus 2z, 3z, 2 plus 8 is 10. Right? Or you can just rewrite them. We could have rewritten these down here and then added, but that one was a little bit easier because they were actually adjacent to each other. When they're right next to each other, it's a little bit easier just to add them straight up. This next one, we're going to need opposite of 4x here. So minus 4 times row 1 plus row 3 will give us the new row 3. So minus 4x minus 4y minus 4z is minus 8. Rewriting the third row, 4x plus y is 4. Adding them together, negative 3y minus 4z is 8 is negative 4, is what I've got. That's good. So now here's our new system. X plus y plus z is 2 this time. 4y plus 3z is 10. Negative 3y minus 4z is minus 4. Okay. Now, 4 and negative 3 meet at 12, so for the next step, we're going to do 3 times row 2, giving us 12y, and then we're going to need 4 times row 3 to give us minus 12y. That will give us hopefully a new row 3 with z's only left. And again, from that last problem reminder, we did get the second stair step, right? And then when we finished, we rolled it, right? So well, that's where we're at now. We're using this one to eliminate the y's in the third equation. So we got 12y plus 9z is 30. 4 times the third equation, negative 12y minus 16z is minus 16. Again, negative 7z is 14, so z is minus 2. And again, you can technically rewrite your final system if you want, but at this point, usually I'm ready to back sub, and I'm back substituting. So 4y plus 3 times negative 2 is 10. And again, that came from up here. We're like, where did that come from? Now that we found z, we're back here. So this is minus 6 plus 6 to both sides. 16 is 4 times what number? Y is 4. So I got 4 negative 2, and then we have x plus y plus z is 2. 4 plus minus 2 is 2, so subtract 2 from both sides, and x is 0. My answers were 0, 4, negative 2. Double check when you get weird answers like that. 0 plus 4 minus 2 is 2. 12 minus 4 is 8. 4 is 4, so it did work. The final answer was 0, 4, negative 2. One last one to get into. And it looks a little bit weird, and it should. If it doesn't look weird to you, it's because we have 3 variables and only 2 equations. So let's see how this one would work. You still try to make the stair step situation, row echelon form, right? So 2 goes into negative 4 2 times, because we do want opposites. So we're going to do, again, writing out what we're doing, 2 times row 1, adding it to row 2 for my new row 2, and we get 4x minus 6y plus 2z is minus 4. Rewriting the second equation, negative 4x plus 9y is 7. Adding, I get 3y plus 2z is 3. And so now I have these 2 equations. Plus z is minus 2. 3y plus 2z is 3. And I don't have enough to solve. So here's what you have to do. We're going to have infinite solutions, right? So instead of saying no, does not exist, we're actually finding the specific infinite solution answer we have. So what we're going to say is z equals some number. Now, because we're not going to say z is 3, z is 5, what we do is we kind of put it in not so variable but letter form, right? A is going to stand for a constant. And by saying z equals a, this gives us our third equation. We're now going to back sub and solve in terms of a for the other 2 variables, right? Because we ran out of, right, we finished our stair stepping because we ran out of equation. So this is where we have to suppose z equals a. If z equals a, what does y equal? So back substitution looks like this. Your solves may look a little more, I like to call it y equals mx plus b, but specifically we're solving in terms of z. Right now we got negative 2a plus 3 is 3y, divide each piece by 3, and we get y is negative 2/3 a plus 3 over 3, or cleaning it up, negative 2/3 a plus 1 is y. One more time to solve for x. 2x minus 3 times what we just solved, negative 2/3 a plus 1, plus z, which again is a, equals minus 2. And now solving this one, don't forget to distribute correctly. Negative 3 times negative 2/3 is positive. The 3's cancel and we just get 2. Right? So if you just multiply the top, 6 over 3 gives you 2. So that's 2a minus 3 plus a equals minus 2. And don't forget we have 2x in front. So I see we've got 3a minus 3. So then we're going to do the opposite. Minus 3a plus 3 to both sides. And so we got 2x equals minus 3a plus 1. 3 minus 2 is 1. Divide by 2. So we got x is negative 3/2 a plus half. And there's our answer. So our answer is in the form of pretty much x, but negative 3/2 a plus 1/2 is our x. Y was negative 2/3 a plus 1. And z was singular version of a. And then that looks goofy, but that is a specific form of our infinite answers in terms of a. That's going to wrap up this lesson. Your homework is posted on Google Classroom. As always, let me know if you have any questions.